Hello, welcome to this new video. Today we are going to be introducing GKE Autopilot, which is a new offering by GCP to manage even better your Kubernetes clusters. GKE Autopilot is fairly new. It was launched about a month ago, and Adler was a launch partner, so I decided to give it a try and see what all the fuss is about. So let's start by introducing a little bit the concept of GKE Autopilot, and we will be switching between this and a little bit of a demo that I've prepared so we can see how it works. So to introduce GKE Autopilot, I think it's important to understand a little bit, very high level, the Kubernetes architecture. So in Kubernetes, you have what it's called the control plane nodes, where those nodes are the ones that run the API server, the controller, the scheduler, etcd, etc. So the main components that make a Kubernetes cluster are the control plane nodes. And then you have your worker nodes, which have to run the container runtime in the kubelet and are the ones that run your workload. So are the ones that run your containers. That said, the control plane nodes also may or may not have the kubelet and runtime to run containers, but it's not necessary. So this is a Kubernetes cluster, and when you're managing your cluster yourself, you're managing all of this. But if you're using a managed service like GKE on GCP or AKS on Azure or EKS on Amazon and others, usually what happens is that the cloud are the ones who are going to manage your control plane nodes. They charge you a fee for them, but it's you don't have to take care about security updates or anything like that, or capacity planning, because they are all going to do that for you. And that already removes a lot of the management overhead for you. So this is a great way to start with Kubernetes if you don't have to have a lot of flexibility on the ways you run the control plane, is to delegate that to the cloud, and it's going to be better in the long run for you. So that's an offering that it's been there for a long time. It's pretty mature. It's very well used in the cloud, and basically, GKE Autopilot goes a step a little bit further and say, what if not only I manage for you your control plane nodes, but I also manage for you your worker nodes? What are the benefits of that? That means that you don't have to take care about things like node pools, capacity planning for the nodes themselves. All of that, upgrades, etc. All of that is going to be managed by Google. So it also comes with some limitations if you run GKE Autopilot, but definitely it's a little bit a step further in the trying to delegate as much as possible to the cloud. So let's jump quickly to this terminal first, and let's see how that's my GKE Autopilot cluster look like. So basically, what I did is to run a create command for Autopilot, and by default, it's going to create a default node pool and 2 nodes. So these are the 2 nodes that are already running when I run GKE Autopilot. So if I check my kube system namespace, I can see that there are already some pods running to run the cluster itself. Those pods are the ones, for example, that are being managed by Google as well. So all of that is managed by GCP, and you don't have to really care about it, a lot of it. So one may think, so how do I run workloads if I don't manage those node pools? How all these things works? So let's see this example that it's very simple. It's an Nginx pod, and basically, GKE is going to take this description of my pod And based on the requests that I made for memory, CPU, and ephemeral storage, so for example, if you have to use an empty dir or for logs, etc., it's going to take these three things and it's going to either create it on the same nodes already running, if it's possible. If not, it's going to add capacity. And it's going to add capacity based on that, but with some caveats. So it's not going to take this exactly as it is, and it's going to give me exactly what I ask. Why? Two things. Because there is minimums resources. So the minimum resources for normal pod is 250 millicore, and as you see, I offer 100. I ask 180. So that's definitely going to change. And also the ratio in which it's going to move the CPU and memory, it's 165 to 165. So for example, if I ask for 250 CPU, which is what it's going to ask, it's going to say, okay, the minimum is 1-to-1, 250, but actually it's going to do 512 because of that minimum requirements that I have. It's also going to have some defaults. These are the defaults. So if you don't put your resources definition in your pod, it's going to say, okay, by default, if there is nothing described here, I'm going to do 500 millicore for pods in a deployment, for example, and 50 millicore for those on daemon sets. So these are things that you need to take into account. The important bit here is the pricing will be based on that CPU, memory, and storage per second that was in the end planned for you. So if in the end, instead of 180 millicore is 280 millicore, that's what's 250 millicore, sorry, that's what you're going to get charged for. So let's have a look to this one. We have this pod, if I'm in the right place. So let's see this deployment. So it's basically the same thing that we've seen before, but just as a deployment, just instead of a normal pod. I'm asking 280 memory, which probably is not going to be possible, and 730 millicore. And the thing is that it's going to do 250 millicore steps. So probably for CPU, it's going to request 750. Let's give it that a try. So if I'm asking for that, deploy. So the first thing it says is a warning. It says, we increase your requests because it didn't match what we offer on GKE. And it gives you a link to understand why that is happening. So if we now check the pods in our system, we see that this is pending. And the reason why it's pending is because probably there is no space in our pool as it is. So it's trying to add more capacity. So it's going to take a couple of minutes. While this is doing its job, we can actually describe the pod that it was created. It says here that there is insufficient CPU, so it trigger scaling up. Again, you don't have to think about these things. It's going to be done for you. But we can see the requests, how they change. So basically, it changed CPU to, as I said, 750 millicore, and the reason why it goes in 250 millicore steps. And then memory, it said 1/3 of a gigabyte. And the reason is that relation 1-to-1. So I asked for 1/3 of a core, so I got also 1/3 of memory, 1/3 of a gigabyte of memory. Cool. So this is probably going to take a little bit while. We can check. Let's clear this thing up first. We can see here that the node was already provisioned. So this node wasn't here before. It was provisioned because this is needed for this pod that we are trying to deploy. We can see the node itself as not ready, because obviously it takes a little while to join that node into the cluster. Cool. So talking about nodes and talking about pricing, one thing that it's also important to know is that obviously when you're running a Kubernetes node, you have to run some components. You have to run the kernel of your operating system, the operating system itself, container runtime, a kubelet, all those things to be able to run your pods. So when we describe one of these nodes, let's describe the new one that it was just created, for example. When we describe one of these nodes, we can see here let's say this is maybe not ready, so let's take another one. So we have here the capacity of the node and what you can allocate on that node. And those numbers are a little bit smaller. So you have here that we have 2 virtual cores on these nodes, but only you can allocate a little bit less than a core. And the reason why is because all those components. The good news is that GKE is not going to charge you for those things that you have to run for sure on every node. So it's not going to charge you for the CPU that is consumed or the memory that is consumed by the kubelet, container runtime, the kernel, the OS, any of the Kubernetes components that need to run as well. So all of that is out of your final billing. So you only pay for the capacity of the workloads that you're running. Important things, GKE Autopilot is not 100% Kubernetes as it says. So you cannot use everything that is out there for Kubernetes. It has some restrictions based on how they manage the cluster, and also some restrictions for security on top. So things that you cannot use is things like host port, host network, host namespaces. Host path you can use a little bit read-only, only for Verilog, for example. You have a very limited set of Linux capabilities that you can use on your pods. You also have some limitations for node selectors and affinity, and you can use privileged pods. So important, GKE Autopilot is not for everyone. So if you have to run workloads that require some of the things that are restricted, probably you need to use something else. But for most people that are running just applications that don't need to use these options, GKE Autopilot is a great option because you don't have to manage all these things yourself. Cool. So how are we going to run Datadog? Datadog uses, for example, things like host ports. Why are we able to run this? We are going to deploy the Datadog node agent that is going to be running as a daemon set on all those nodes, and the cluster agent that is going to be a deployment that it's basically going to gather capacity, gather metrics from the API server. The reason why we can run, as I said, Datadog was a launch partner. If you get the custom resource definitions that are on your cluster, when you run these things, as you can see, there are many of them. So Google has done a lot of stuff to improve. You can see that there is a lot of gatekeeper stuff. So if you know, gatekeeper is policy enforcement for Kubernetes. And that's the thing that it's going to stop you from running the things that they don't want you to run. But let's check this thing. So if you check this, this object that was created for us, there is something that this is only for them, that workloads that actually can run and can overpass some of these limitations. And one of the things that can run is Datadog agents. So this is already on your cluster when you're running. So that is going to allow us to run the cluster. So good. So let's see if I'm going to switch to the scene. 1 second, so you don't see my window, because I'm going to type my API key and my app key for. So hopefully that's done. Good. And now we are going to install Datadog. And something that I had to do when I was playing with this, and probably something that you need to take into account, beam packing. So it's difficult. Beam packing is trying to fit all the containers based on the capacity on a node. It's a difficult concept. It's very difficult to get it right. And same thing happens with GKE Autopilot. So what happened to me when I was trying this is that the Datadog agent needs to run as a daemon set, to get information from all the kubelets that are running on your cluster. And what happened is that in some of the nodes, there were not enough capacity. And because of the priority of the daemon set wasn't high, it would stay as pending. And if it stays as pending, I don't get information from that node. So I'm a little bit on the blind on that particular node. So what I did, and while this is running, we can see it. So basically what I did was to create a new priority class, high priority, and give it to this daemon set. So something to take into account, because it can happen to you as well, not just for Datadog, but for any daemon set that you really need to run on every single of your nodes. It may happen that it stays as pending, which is not ideal. So let's see. So just to give you an example, this is the priority class that I created to make sure that at least the Datadog agent node agent had enough priority in the list. Cool. So if we get now the pods, we can see several things. So we can see a couple of Datadog agent running. This one is initializing, and this one is pending. And the reason why it's pending is probably because, again, there is not enough capacity on the current nodes for the cluster agent. So it's going to create yet one more node for me. Again, you're only going to pay for the pods that you're running and not any other capacity that GKE decides to give to you. So let's see how this is going. You can see here that now we have probably a new node. You can see it here. It's adding that capacity for me in an automated fashion to make sure that all run. And again, beam packing is difficult. So one of the things that you're going to see if you're using GKE Autopilot is that once you add more pods to your cluster, probably GKE is going to reschedule a bunch for you. So one that was running, like the Nginx pod was running correctly, it moves back to pending because it decided to move it to a different node. So that this can happen. This is going to be fully automated for you. again, you're only going to pay for the capacity of your pod. So even though nodes gets created to then reshift everything and then they get destroyed, you should be safe. You're not going to pay for that. But something to take into account, that once you add your workloads, it may take a little while to have everything together. So let's see how this is going. As you can see, Nginx is back running. Things are moving around. So let's see, because we already have some Datadog pods running, sending information to Datadog, let's have a look to how this is going. So if we go to here to the infrastructure, we can see here the nodes that are already running the Datadog agent. Again, once more nodes are running and the agent is running, we will see more of them here. What else we can see here? So the list of containers that is running on our cluster will be appearing here. So you have not only the ones that are running for your workload, so not only the ones like Nginx that you wanted to run yourself, which is this one, but also any other that was already running and was managed by GKE. And this is super important. Like, even though you don't manage those components yourself, it's important to continue to have visibility on those, to monitor those, to understand what's going on, because software can go wrong, as we all know. So it's important to know, even though it's not for you to fix any problems, but it's important for you to know about them. So we have here now all the nodes. We can see here our cluster, and we can check the number of pods that we're running, all the information. And this is also super important. As I said, obviously we've been doing a little bit of checking how these things were moving around in the terminal. But if you have a big cluster, it's important that you have the visibility to anything that is happening on your cluster in real time. So we can see here all the replica sets and deployments, the different nodes. Again, very important to check how that capacity is being added. So you have here a view to see all the nodes that you have with the capacity and how they were deployed. So super important to understand the state of your cluster at any given point. Same thing with anything else, like your Nginx deployment, for example. Good. So that was a little bit of introduction of what is GKE and what it's for. I hope that you learned something. If, again, super interesting project by Google. If you think that you don't need all the things that are restricted in the list of restrictions that are documented on their website, I think it's a great way to start with Kubernetes, because again, you don't have to think about node pools, capacity planning of your nodes, etc., or even beam packing. So as you saw, they also reshift everything to have the less capacity as possible. So thank you very much, and see you in the next video. Thanks, bye.